Optical instruments, principles and theory involved in lenses led to an idea of designing of optical instruments like microscope, telescope, cameras, and that to advanced cameras. Let us have a discussion on them separately. Let us have a discussion on microscope. What is microscope? Microscope is a device designed to magnify the image of the tiny object which we cannot see with the naked eye. And using this magnification, we have explored the micro world by observing and analyzing the internal structure of the tiny objects, whether living or non-living. There plays an important role microscope. In microscope there are two types: simple microscope and compound microscope. In simple microscope, single convex lens is used to magnify the image. In compound microscope, two convex lenses are used to magnify the image, which can enhance the magnification as well. Let us see what is a simple microscope in detail. Only one convex lens we have. As you know, the optical property of convex lens, it depends on the position of the object. If the object is within the focal length of the lens, between F and O, that is the focal point and the optical center, within the focal length of the lens, if the object like this, the light rays from the object diverge like this to produce image on the same side, that too a magnified image, and it is a virtual image, not real image. If the object is beyond the focal point, focal length of the lens, somewhere here, and the light rays from the object converge and produce the image on the other side of the lens, that image is real and inverted, of course magnified. It is not shown here. If the object is at exactly the focal length, focal point of the lens, the light from the object neither converge nor diverge. They remain parallel like this. Produces the image, that is a virtual image at the infinite distance. That is a kind at the point B diagram. And the diagram shows this object produces a magnified image like this. In simple microscope, the object is always placed within the focal length like this. Produces an image like this: magnified image, virtual image, and erected image. You have to concentrate on the magnification. Let us recall the definition for magnification. Magnification, we have the definitions like this. It is in terms of height, that is ratio of the height of image and height of object. It is in the form of ratio like this, of distances, image distance and object distance. And also we can define the magnification as a ratio of these angles, that is theta I, theta naught. Let us understand what is theta I and theta naught. In this diagram, here it is extended. There is a object at this distance. To find the image, the position of image, you can take any light rays. I am taking any two light rays from the point on the tip. One light ray is parallel to the principal axis and other light ray passing through the optical center. One which is passing through the optical center never undergo any deviation, and the light ray passing parallel to the principal axis undergo deviation like this, passing through F. It is a light passing through, and these light rays never meet. They are always getting separated. But when you draw them in the reverse direction, they meet at this point. It is a diverging point. So this point of the object is appearing as an image, point of image at this here. So image point, this point is produces, and this point is on the principal axis, this point on the principal axis. So it will remain same. We get the image like this, position of the image. And what is theta high? It is angle subtended by the magnified image. Theta I is the angle subtended by the magnified image. When at the eye, we are reading through the lens. Angle subtended at the eye by the magnified image, that is theta I. Look at this line extension. This theta angle of subtended. And there is also one more diagram. There is eye is here. Here there are two types of visions. Here vision with lens. Here vision without lens. Direct vision on the same object. And what is this? This theta naught is the angle subtended at the eye by the object due to this distance. The object distance, image distance, the difference. But in these cases, this is always larger than this because it is magnified. The ratio is called as theta I by theta naught. Now let us calculate what is theta I and theta naught using this diagram, in this geometrical diagram. Now you can apply geometry like this. Now to calculate theta I, let us apply tangent of the angle. Tangent of the angle means with this angle is a common angle for both triangles, a smaller triangle or larger triangle, right angle. There are two possibilities for definition of tan theta. I am taking this tan of this theta. That is one possible. Hi by V. What is V? Distance of the image from the lens. U is the distance of the object from the lens. So Hi by V, opposite by adjacent. That is one possibility. And one more possibility, because the same angle is for this triangle. H0 by U, opposite by adjacent. You can both of them. Either this or this. Usually go for this because these two are measurable quantities. Tan theta I equals H0 by U. Similarly, apply tan of this angle. Here also right angle triangle. That is the height of the object and distance between the object and the eye. D. Let us call this as D. H0 by D. And in this case, tan theta equals theta, whether theta I or theta naught. Why? The reason, the object under investigation is very small, tiny, micro object. If that is the case, angle subtended will be very small. These angles are very small. If the angles are very small, you know the tan of the function, tan theta equals theta. Apply that. So this is theta I, this is theta naught. So theta naught equals H0 by D. and theta height equals h naught by u using this. Use this. So this is how we have found what is theta high and theta naught using these diagrams, and substitute for them into the equation. M equals the ratio and put them into the equation. This is for theta high, this is for theta naught. H naught cancels and this goes to numerator, becomes du by u. Here magnification by the lens used in the simple microscope is d by u. The distance of object is always within that focal length, and d is very important. Let us define what is d now. D by u, it is a general formula for magnification by simple microscope. Let us understand what is d here. Here naked eye, the object, the same object is here, and this distance, if this is 25, I will call this as 25 centimeter. This 25 centimeter, for every height is 25 centimeter. This d is also called as, this 25 centimeter is called as least distance of distinct vision. What does it mean? What does it mean? It is also called as near point. It is also called as near point. What is this distance of distinct vision? This d. Distance between this and this. Distance of object from the eye. 25 at least. This eye can observe this with clear visibility without a strain produced in the eye. What is d? It is a minimum distance of, what is d now? I said distinct vision. It is a minimum distance of object from the eye for a clear visible without producing any strain in the eye. It is quite nature. For a normal healthy human eye, the value is 25 centimeter. For normal healthy human eye, if eye is healthy human eye, it is usually 25 centimeter. There is little difference, small difference. For all human eye, it is 25 centimeter. So only when the object at this distance from the eye, it is, we can see the object. We can view the object. Comfortable view, comfortable distance for viewing or reading. This 25 centimeter is a comfortable distance for viewing or reading. You can check it. If the distance is less than this, if it is moves closer to the eye, the object becomes blur, producing strain in the eye as well as. You can check it. No clear visibility. If you bring the object closer to the eye, like less than 25 degree, the object, the clarity will be, that is diminished, becomes blur and produces a high strain in the eye as well as. So this is a minimum distance. You can see with a clarity. If the distance is more than this, it is even more comfortable and eye can relax. So that is why least distance of distinction d. It is quite natural. It is always 25 degree. This d is taken as a constant value. Giving this. That is the definition of d. And so this is for a naked eye. And here in the simple microscope, we are using lens. We are viewing the object through the lens as an image like this. If that is the image formation, for an eye like this, of course through lens, what would be the least possible distance? What would be the least possible distance of image because I'm talking image you are seeing. Distance of image for a comfortable view. That is, I'm talking about closest comfortable distance for viewing the image. It is only again V equals D. If the distance between the image and the lens is D, then I can see that is the view, the image with comfortable clarity, the minimum distance. So that is one case. And more than this, it is even more clearer. Less than this, no clarity. If the image is forming at a distance less than D, we cannot see the image even though lens blur in the image. So minimum is this value. So then this is one possibility. In this value, there are two cases here. Limiting values, least value and the highest value. Least value, that is least distance of image for a comfortable view, that is one case, and the highest distance of image for a comfortable view. There are two limiting values. In between, we can see the image as well as least and the highest. The least value is V equals D. For a comfortable view, for a comfortable viewing of image, V equals D. And the highest value for the comfortable viewing of image is V equals infinity. Let us apply this condition to this equation. This condition to this equation, this condition to this equation. Case 1, case 2. And see what we get and substitute for u accordingly. Look at this. This is equation of length 1 by f. Put v equals d with sign convention, Cartesian sign convention. And v is always minus in this direction. But here f is always positive for convex lens. Remember, f is always positive for convex lens. So f is positive. And v equals d, it is minus but is in the direction opposite to this light. And u is minus in the direction opposite to the light direction. It is u minus u. And simplify, you get this. It is 1 by u equals this. In this equation, we have 1 by u, d into 1 by u. Substitute for 1 by u, d into this u. Simplify further, it gives 1 plus d by f. Final equation. This equation for magnification when the image is at least distance for a comfortable view. When the image at least distance for a comfortable view. Equation. This constant and this f value. Look at this. Magnification can be increased by decreasing the focal length of the lens. That is one equation. And what is the second case? When the image at infinity, apply this to equation and see what the equation, lens equation becomes. 1 by f, f is positive, and v is infinity, 1 by infinity, and minus u is minus u in this case. Simplify, you get this. This becomes 0. It is same as u equals f. Put u equals f, d by f. So u equals f means the object at the focal length. This is a diagram. If the object at the focal length, the light rays neither converge nor diverge, remains parallel, the image, the virtual image at the infinite distance. I can view that image even though at infinite distance. That is d by f. So this view, that is viewing this, even though the image at infinite distance, that is of course magnified, it is considered as most suitable for viewing the image by the relaxed eye. We can view that with the relaxed eye. most relaxed eye. So that is the concept involved in the simple microscope. So magnification of the simple microscope here depends on whether the image at the minimum distance d or the image at final distance, is infinite distance is there. So this is the equation, magnification for the image at infinite distance. Again the constant divided by m. It is also inversely related to that. Lower the value, higher the value. So it is understood we can increase the magnification of a simple microscope by decreasing the focal length of the lens. That is what you understood. So this is about the lens makers. Using lens makers formula, accordingly we take a suitable convex lens for the construction of simple microscope. So this is what the concept involved in simple microscope. In the next class, let us continue with the compound microscope. So let us wind up the session for a while.